还有一节课，继续听吗？
Huh? Inferential. Okay. So now, the previous lesson, we moved from data to information, right? From here to here. Now, gaining the information about the sample or the variable we have, we are moving into facts. Sometimes call it testing, hypothesis testing, these kind of things. So data, information, descriptive, and we want to take inferences based on the information gained. So here, earlier from the population, we took a sample. Why do sample? Why not study the entire population? Why took a sample? Why not study the entire population?
Because of ETC.
Because of ETC. But the ultimate aim is to say something about the population at large, isn't it? Right. So after knowing the sample value, it's not like mean, median, standard deviation, right? Proportion. What can you infer or say about the population at large? So that's called inferential statistics. There are two methods of doing it. One is testing, I call it hypothesis testing. Other one is estimation, right? Now testing, we test a hypothesized value. Example, you want to know, is the BMI among the college student 25 a hypothesized value, right? Whereas here, estimation, normally we talk about like a confidence interval. Example, we are confident with the level of confidence that the mean is between A to B, that kind of things. This is more universal. Usually confidence intervals, they are more universal. Whereas here, this is used to test a particular value that you want to know. So here, we use p-values. Have you used p-value before? Have you heard about p-value before?
Yes,
When?
in the past lesson.
For normal,
What?
normal data.
Whether data is distributed normal or not. So this answers only yes, no, that's all. But this tells you more story, more detail. So again, SPSS later when you click button, will give you both the p-value and the estimation. Depends on objective, we'll answer accordingly. All right? Now let's go to hypothesis testing. Now, look at this 2x2 matrix now. The nature, whatever you're testing, can be true or can be false. The decision, it can be to reject or not to reject. Let's see an analogy. Where the suspect is taken to the court, is he a murderer? When the suspect is taken to the, let's say, to custody, is he a murderer or is he innocent? The police come and arrest a person. Is he murderer or is he innocent?
Don't know. Not yet.
Not yet?
Not yet.
Can it be both? Murderer and innocent same time?
Depend on the law of the country.
Law of you're murder or innocent, that's all. Somebody died. You are the murderer or you're innocent. Can't be. Oh, okay, I understand. Certain country, yes. Right? Okay, you're either one. Right? Either you're murderer or innocent. Now read this side, free or hang. So what is this in yellow box? What is this in yellow box? What are you doing in the yellow box? You are
Undefined value.
freeing a murderer, right? This yellow box represents your decision, free a murderer, right?
Mm-hmm.
Is it good? Is it okay to free a murderer? Okay,
No.
this green box, what are you doing? Yeah. What's the decision?
Is innocent, you can let him go home.
You are freeing an innocent. Is the right thing to do?
Yes.
It's supposed to be.
Supposed to be. How about this green box? How about here?
Yeah.
Oh no, now we're going to get a debate on whether to hang a murderer or not.
The right thing to do?
Yes.
Yes. What are you doing here?
Hanging an innocent, no.
you're hanging and innocent. Is the right thing to do?
No.
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 So here is not, here also is not. So only two, either is a murderer or innocent. Can't be anything else. Decision, you free or hang him. Only two, right?
You could just imprison.
Can it be anything else?
Yes, you could just imprison the person.
Okay, prison, right? He doesn't like hangs or prison. Instead of prison, I put sentence, right? Is it better?
Yes.
Perfect.
Sentence you hang or whatever it is. So this yellow box, you free a murderer. This orange box, you sentence an innocent. So these two are not okay, right?
No.
But here, you free an innocent. That's the right thing to do.
Mm-hmm.
You sentence a murderer. That's the right thing to do.
Yes.
So we have, what have we committed here? By doing this, what have we committed? Is that a mistake? Is that a mistake? You free the murderer. Is it by mistake?
Yes.
The judge free the murderer. Is it by mistake?
Yes, it would be a mistake.
Is it by mistake? It could be a mistake. Is it by mistake? Mistakenly free the murderer. Or is it erroneously free the murderer? So what's the difference between error and mistake? What's the difference between error and mistake?
Mistake, you release him directly, and error just you steer under suspension.
Error hasn't got the right outcome,
Mm.
but it's not doesn't judge whether
I think we
mistakes
take
are made
this
or not.
calculation. Mistakes can be corrected. Error is part and parcel of the system.
Mm.
The judge free the murderer. Is it because he liked the murderer? Why the judge ultimately free the judge knows he's a murderer?
Lack of evidence from
Evidence. The error, where this error is not a mistake, said to be committed when a murderer is freed. Why the murderer is freed? Because of evidence. So we call it, we are committing an error. That error, okay, we are committing an error here. Look at the next one. Type 2 error. Why the innocent was sentenced? There are people after 40 years in prison. Ultimately, they found he's innocent and released. Right? So now, why the innocent was sentenced in the first place? Why the innocent was
Got framed.
sentenced? Yeah?
Got framed.
The
Framed?
judge was biased.
Judge was not biased. We assume judge is not biased.
Okay.
Because evidence, right?
All right.
Because again, based on evidence, right?
Mm-hmm.
Right? So this also is an error. So error is part and parcel. So in your research, in your study, from the time you started to do a research, collect data, analyze it, there will be some errors accumulating, uncertainties accumulating, right? Finally, even a truth could be rejected. Before, just complete this now. Now, between these two errors, are they same? The magnitude, are they these two committing here error, an error here? Are they similar or different?
Different.
They're totally different.
Absolutely different.
So differentiate this, we call it type 1 error, and we call this type 2 error. It's not that 1 minus this becomes this, no, they're totally different. When you free the murderer, you are said to commit type 1 error. When you sentence innocent, you are said to commit type 2 error. Now, between these two, which is more
That's
serious?
good.
Between these two, which is more serious? Type 1 or type 2 error?
Both are dangerous actually.
Which is more serious?
Type 2?
Innocence, type 2.
Innocent being hanged is more serious?
Or type 1.
Well, tell me, which is more serious? Type 1 or type 2 error?
I think type 2.
I think type 2.
The type 2 error means what? You are sentencing innocent.
Yeah.
You know what I'm
Yes.
telling? Okay.
Yes.
This is your house. This is your house. Okay, your house, okay, you right? This is murderer's house. This is innocent's house. Which are you more concerned with? Innocent coming out or murderer? Innocent, okay, this murderer. Which are more you're more concerned with? Murderer coming out, innocent being sentenced.
Murderer.
Murderer coming out.
Huh?
Murderer coming
Murderer
out.
coming out.
Just now you say other way around?
For me, both, it's not.
Type 1
No,
is
which is more serious? That's asking. Both are okay, not good. Which is
I,
more
I
serious?
type 2 is more.
Type 2 is more serious.
Yeah.
You free the innocent. So you sentence the innocent more serious for you. But the murderer comes, okay.
type 1.
The murder,
Type 1 now, yeah.
Yes. Okay.
the murder took place here. You are the eyewitness. Who's next? The
Dog.
murder took place in front of your house. You are the eyewitness. Who's next when the murder comes up?
We are.
Are you?
Then the
You'll be
situation
you.
changes.
No,
You're
situation.
the only witness means you. You'll be
You.
more.
So you
You'll
are
be
next.
killed. You'll be killed.
Now, are you more concerned murderer coming out, innocent going up?
Murderer coming out.
Murderer coming out. If the murderer come out, more murders will take place, right?
Yes.
The innocent being sentenced, let's say behind bars, nothing will happen outside, right?
No.
Right. So between these two, by general consensus, type 1 error is said to be more serious than type 2 error. So in statistics, whatever truth, it can be true, whatever we're talking about nature can be true or can be false. But based on our data and our analysis, sometimes we tend to reject even the truth, right? Murderer, free. Because sometimes we false, we're not able to reject it. So said to be committing the two types of error. So in statistics, error bigger the better, smaller the better.
Smaller the better.
Smaller the better. How do you quantify this? So now you call type 1, probability of type 1 error. Probability of committing type 1 error, that's a p-value, right? Normally symbol alpha. So what's the p-value? Probability of committing type 1 error, also known as the level of significance, or sometimes also called the p-value. Have you heard about p-value before? Have you heard about p-value before?
Yes.
Yes.
Yes, we have.
That's exactly the p-value. So probability ranges from, what's the range for probability? Ranges from
0 to 1.
0 to 1. 0 means what? Probability 0 means what?
There no
Probability 0 means
No occurrence.
does not happen
False.
at all, right? 1 means happens all the
True.
time.
All the time.
Sure.
All the time. So now we want this probability to be close to 1 or close to 0.
0.
Close to 0. As small as possible. We want to maintain this as small as possible. How small? By convention, less than 5%. We don't want the error to be large. We can't expect the error to be perfectly 0 because we are doing sample, not population. So we allow a 5% error. That's why I said the p-value less than 0.05 data is not normal, right? So that's where the p-value came from. So the alpha, also known as the p-value, is actually probability of type 1 error. You okay?
Doctor, sorry,
Yeah.
Doctor, I have to leave as my class will start right now.
Okay, sure. All right.
Thank you. Thank you.
So that's your type 1 error. Are we clear? So must be less than this space here. Should not be more than that. Type 2 error. So type 2 error not covering here. Type 2 error should not be more than 20%. So type 2 error, type 1, have it here now. No. Okay, type 2 error. Type 2 error should not be more than 20%. Okay, again, this being error, smaller the better. How small? Should be less than, right? This one, less than. So now, first one, less than 5%.
0.18.
This is less than 20%. So which one you're considering to be more serious?
Type 1.
Type 1 error. You're taking type 1 error to be more serious, right? Very small. Whereas type 2 error, a bit more lenient, right? Okay, let's take type 1, type 2 error in terms of this murder and innocent case, all right? So type 1 error. 5% means what? Type 1 error probability, type error 5% means what?
Out of 100 murderers, 5 are set free.
Out of 100 murderers, probability type 1 error must be less than 5%. 5% means 5 over 100, right?
Yes.
5 over 100. It means out of 100 murderers, you can free not more than 5. Not more than 5. So type 1 error 5% means out of 100 murderers, you can free at most only 5. Agreed?
Yes.
Right? Out of 100 murderers can free not more than 5. That's what 5%, less than 5% means. Agreed? Class agreed?
Yes.
Right. Type 2 error 20% means what?
Out of 100 innocent people, 20 can be hanged.
Right. Out of 20% means out of every 100 innocent, can hang, right? Can hang only about 20. Don't hang too many. Hang too many, time will come, nobody to hang. Right? So by analogy, this is what it means. That means that this is taken more serious compared to this. Of course, in our research, we want this to be smaller the better, right?
Yes.
These two errors, we want this to be small as better, right? Smaller the better. How to make smaller? When sample size increases. When sample size is large, both errors will be minimized. And that's why the sample size calculation comes into place. How big a sample size do we need to keep this error?
Sorry
Yeah?
to. Is this p-value same as in the normality what we have seen?
Same. P-value, the concept is same.
But for the normal distribution, it's like the p-value should be more than 0.05, right?
No, P-value more than, you're asking whether data, is it normal or not normal, right?
Yeah, right.
Right. For the P-value,
Is there any relation? That's what I want.
let's say here, I put normal. Here we say not normal. Maybe I put this one here. It could be normal or not normal, right?
Yeah.
Not normal. Reject. Actually, what are we doing here? Tell me what are you doing here? Something is normal, but you're telling it's not, isn't it?
Yes.
There's an error, right?
Yeah.
So that's you're committing error, isn't it?
Yes.
How big error are you committing? Supposing p-value comes 0.001 means what? The p-value comes 0.001 means what?
It's not normal.
Okay, that being normal, and you're rejecting, the chance is 1 in 1,000. The distribution will be normal, and you're telling
Okay.
it's not normal, the chances is 1 in 1,000. What does it mean? Most likely it's not normal, right?
Yeah, right. But the p-value should be more than 0.05, right? In
No.
the normal distribution.
That's why we're testing. The p-value more than 0. Okay, supposing the p-value comes out 0.701 means what? That being
Yeah.
normal,
Yeah.
and you're rejecting it, very high chances, right?
Yes, it
That
is
means
more.
perhaps it must be normal, isn't it?
Yes.
So p-value more than 0.05, we conclude perhaps data is normal.
Yes.
P-value very small, less than 0.05. I mean, perhaps this is not true, isn't it?
Yes.
This one, you didn't make a decision. The data made a decision, right?
Yes.
Based on the data driven. So the p-value comes like that. Hey, chance of making this error is very small. Most likely, it's not normal. When it comes like this, chances of making this error is very high. Perhaps data is still normal. So time being,
Okay.
don't
Yeah.
go into all the nitty-gritties, okay?
Okay. Okay. Fine.
What I tested, is it normal? What's the p-value? Less than 0.05, it's not. Is it normal? What's the p-value? More than 0.05? Yes.
Okay. Okay.
Right, but
Fine.
underlying principle is how it works.
Okay.
Are you okay?
Fine.
All
Yeah.
right.
Fine. Thank you.
So based on this, so this class, we're talking mostly on this. So what is the 5% chance? Yeah. Question? Somebody ask question? All right. So that's the analogy you want to use. So from this class onwards, so all these are based on this standard normal distribution table. Right? For to be normal, must be symmetrical, must be bell-shaped, and based on the area. Look at the area under the curve. 0 to 1. So what's the area under the curve 0 to 1? 0 to 1. Let's say until here 1. What's the area under the curve? Okay, this until 1, let's say. What is this area? That's area 0.16. From 0, let's say it's 1. So 0 to 1, the area is 0.16. Round it up. 0.16. Is it okay? 0.16?
Yes.
This side 0.16 by symmetry. On this side also must be 0.16, right?
Yes.
Sorry, 0.16 tail area. From here onwards 0.16. This 0.16. How much by this area? The whole area under the curve, how much?
0.5. Oh,
The whole area under the curve.
1.
1.
Yes.
This how much? This area how much?
0.5.
0.5. 0.5. So 1, this measures the tail area. This tail area equals to 0.16.
0.16. Yes.
So what must be this area?
0.5.
Now this area. 0.5 is from here all the way up, isn't it?
Yeah.
What is this area?
0.5 minus.
Yeah.
0.1.
Was 3.5,
Ah,
0.35.
This is 0.16. This much 0.34, right?
Yeah.
Yes.
0.34 times 0.34?
0.68.
68. That's what I got, right? Roughly 68% must be within plus or minus 1 standard deviation. Let's go to 2 standard deviations. Let's say that's the area. 2 standard deviations. What's the tail area for 2 standard deviations? 2 standard deviation, what's the area?
0.023.
Okay, round it up. 0.25?
24.
0.25,
Yes.
okay? If this 0.25 on this side, this must be 0.75, 0.475, right?
Yes.
If this 0.025, This must be 0.475475, right? Times 2? Times 2?
Another 0.475.
95%, right?
Yes.
0.9.
95%.
Right.
Yes.
3 standard deviations. From here goes until 3. What's the area there?
0.001.
0.001. 0.001, the 0 on the left and right, 0.001.
98%.
Almost 99%, isn't it?
99%. Yes.
So the cutoffs now, the cut plus or minus 1 standard deviation, plus or minus 2 standard deviations, plus or minus 3 standard deviations. It's all are derived from these computations. But nowadays, you don't bother about this, right? A normal distribution, what does it mean? Symmetrical, it must be bell-shaped, and they partition this by mean and standard deviation. The area under the curve must be roughly 68, 95, almost 100%, right? So this table is heavily used in almost every industry,
Oh, thank you.
right? Almost every industry, correct? Especially medical. What's normal body temperature? Okay, 39 degrees Celsius means what? 39 degrees Celsius.
38.6 is normal.
How do you know? How do we know that?
That's how it's been marked in the thermometer.
Okay, how do they know? How the doctors know about this? Who told the doctors? Right? So
They tell
we
us.
need to study first. Right? Many studies have been done to see what is the mean body temperature. Right, so that's all. Listen now. First must study this first, right? What's the mean and what's the, what is this? First must study what's the mean and what's the deviation. Let's say this example. Let's say mean body temperature is 37, standard deviation 0.5. 37 and 0.5. Where's the center now?
37.
37. How much is here?
37.5.
5. How much is here?
38.
How much is here?
38.5.
So anything more than 38.5, not normal, right?
Yeah.
So we have studied this again and again under normal population. Supposing this is 37 plus or minus 0.5, then we know 37 centered here, plus 0.5, 37.5, plus 0.5, 38, plus 0.5, 38.5. So anything more than 38.5, not normal. As simple as temperature. How many variables do you have within ourselves? Temperature, BP, triglyceride, whatever it is. All these people are studied. When you go a blood test, right? Blood test is a 18.21 blood test. How does the results come up? They give one interval, right? And see whether your value falls inside or outside, right? Have you taken blood test?
Yes.
Right.
Yes.
When it's outside, they put an asterisk sign, isn't it? Not normal, right?
Yes.
But who develop all the cut points? By this kind of studies.
Yes.
Right? What is the interval for, let's say, triglyceride? What's the interval for cholesterol? What's the normal range? What's not normal? So once you have this graph done, you take a value, in this case, temperature 37, temperature 38.5, above is here. Similarly, this is already too cold, right? So this will be what? 36.5, 36, 35.5. So anything more than less than 35.5, you could generally may say it's not so well, having cold or whatever it is. So is statistics important?
Yes, it is important, Rob.
Right? How many parameters go for blood test, or how many parameters, how many tests they do? All are testing against some standards. Where the standards came from? This kind of studies, right? Okay. Questions? Okay, that's all you need to know about this type 1, type 2 errors for time being at least. What is type 1 error? What is type 2 error? Right? Especially the results comes out, example here asking, the population mean is 25. Right? We are testing the population mean is 25. If the p-value comes out in the test later, 0.002, what does it mean? This means the mean BP is still mean 25, and you're rejecting it. The chances are 2 in 1,000. Very slim chance. Is it a very slim chance?
Yes, yes.
It being 25 and you're rejecting it, the chances are 2 in 1,000. Very, very slim. So most likely this is not true, right?
Yes.
Then this must be true, isn't it? Most likely this is not true. We reject it. Reject it, then it's not 25. If the p-value is 0.305, now what's the conclusion? This being true, and you're rejecting it, there's a high proportion, probability is very high chance, right?
Yes.
I mean, most likely, we should not reject this. We say do not reject this. Okay, the p-value less than 0.05, we can reject H null except alternative. The p-value is more than 0.05, we cannot reject H null. Perhaps the mean is still 25. So later, from next week onwards, we're going to do testing. After testing, we want to know whether the mean is this. If I want to know the mean between the two populations similar, we want to know whether the drug is effective. We're going to run some analysis, get some p-values. Based on the p-values, we make a decision. So make an objective. For example, I want to test whether mean BMI are they similar between male and female. Means by mean BMI, male equals to female. Right? Example, to test if the mean BMI for the male and female are equal. What must you look for? What do you look for to answer the question? I'm asking you, okay? It's a mean so IQ. Is a mean IQ between male and female, are they equal? What's the answer? IQ between male and female, are they equal?
Maybe.
What must you ask me? You must ask me what's the p-value?
Yes.
Okay, my question again. IQ from male and female, are they equal? You ask me what's the p-value? You understand what I say?
Yeah.
The same way, you're going to enter data and SPSS, click some button. Why are you doing this? We want to know certain thing. I'm asking you, right? IQ of the male and female, are they equal? What must you ask me?
P-value.
What's the p-value?
Yes.
P-value is 0.001.
1 in 1,000. Yeah.
So what's the answer? My question is, are they equal? So what's the answer?
1 in 1,000, right?
No, what do I want to do? Are they still here? I'm asking whether the IQ, male and female, are they equal? P-value less than 0.05, it means no.
No.
Not equal. Yes. They are not equal. Is the data normal? P-value less than 0.05, not normal.
Not normal.
Are the IQs the same? P-value less than 0.05, not the same.
No.
Right? Another question. Blood pressure, smokers, non-smokers, are they equal? Or is there a difference in blood pressure between smokers and non-smokers?
P-value?
P-value 0.725.
725. Yes.
P-value 0.725 is more than 0.05.
Yeah.
Yes.
Therefore, no difference.
No difference.
Isn't it? Is there a difference in blood pressure between vegetarian and non-vegetarian?
P-value.
P-value is 0.002.
No.
Huh?
Less than 0.05.
P-value less than 0.05 means not the same. Not the
Not
same. Okay, just remember that.
Yes.
P-value less than 0.05, not the same. Okay? BP between vegetarian and non-vegetarian are the same?
P-value?
P-value 0.725.
Yes.
Guess what?
But more than 0.05.
Different or not different? Blood pressure between vegetarian and non-vegetarian are they equal, right? P-value 0.725 means what?
More than P-value is more than 0.05.
More than 0.05.
It's the same.
Or it's the same. Or we
Same.
say no difference.
No difference. Okay.
No difference. The p-value is 0.001.
Not the same.
0.001.
There's
Less than 0.005.
okay, difference or not, no difference, okay?
No.
Say difference or no difference. Right. The height of newborn babies, male and female babies. Is there a difference in height of newborn babies between male and female? Is there a difference in heights of newborn babies, male and female?
P-value.
P-value is 0.727.
727.
Same.
There are difference.
No
Answer?
difference.
No difference.
No difference.
Right?
Yeah.
Yep.
BMI among teenagers between male and female. Are they similar or different?
P-value?
P-value is 0.002.
0.002. Less than 0.0.
Not the same.
Yes.
That's a difference.
Different.
Difference.
There
Yes.
is difference. Right? Keep it layman's. Okay, is that same? Is it similar or different? Are they similar or different? Or there's a difference or no difference? Whenever p-value less than 0.05, is it there's a
Yes,
difference?
different. Yes.
Means what? Not similar.
Not similar.
P-value more than
Okay.
0.05 means there's no difference.
No difference.
That means they are similar, right?
Yes.
Right. That's the idea we're going to take from here.
I see.
Right?
Yes.
So this is very important. Basic understanding of this is very, very important. Okay? Okay, tomorrow I'll check with the ICT why the problem with the SPSS. So you're telling you can download SPSS but cannot download my data, right?
No,
No,
Professor.
data is downloaded.
For those who are
but we
using
couldn't.
remote desktop,
Say again?
for those who are using remote machines, right?
Remote machines?
How can we transfer our data on the remote location?
Right. Those using remote machines cannot download the data, right?
Yeah, because
Okay.
it's on our local machine and we
All
can't
right.
access the data.
Okay, I'll check with the ICT tomorrow. All right?
Yes, Professor.
Right.
There is one more way. You can go to Google and just type SPSS register. It's free for 1 month.
1 month.
Yes.
You want to try that?
So this is the alternative. Yeah. So I tried it. So
Yeah.
I'm using it. Yeah.
Right.
So it's free for a free trial for 1 month. Yeah.
That is a better alternative, right?
Yeah.
Can you,
I mean,
can
for
you
time being.
yeah, because only 7 weeks. Now, can you send the site, the extension to in the group?
Yes. I
link.
will send the link over.
Okay.
Yeah.
I think
In the
next
WhatsApp group.
you do that.
Can we use PSPP, Professor?
Can, but you can get this 1
Can.
month license. We start with this first,
Okay.
right? Within that, you can finish. Okay.
Fine.
All right.
Okay.
Okay, we stop here
Thank
today.
you. Yeah.